For example, it is given 4 men can do 2 units of work working 5 hours a day in 24 days. Then 6 men will do 3 work working 6 hours a day in how many days? Now remember, the answer may be in fraction, not necessarily that it will come in integer form. Now how do we deal with this question? One approach which we need to understand while solving such questions is the concept of direct variation and inverse variation. Now remember, here we are assuming that the relationship is linear. Okay? So what we understand when we say A is directly proportional to B, or A varies directly with respect to B, it can be said that when A increases, B increases, when A decreases, B decreases. Similarly, if B increases, A also increases, and if B decreases, A also decreases. Okay? And another relationship, if A varies inversely with respect to B, it means if A increases, B decreases, and vice versa, and if A decreases, B increases, and vice versa. Now, what is the use of this particular thing in this situation? I will put in a simple way. Okay, let's assume that if I want to increase a value 15, there is a value 15 which I want to increase, and I have been given 3 choices. Either multiply it with the number, let's say 1.2, or multiply it with the number, say 1, or multiply it with the number, say 0.7. Now the moment I multiply 1.2, the answer will become 18. The moment I multiply with 1, the answer will become 15, and 15 into 0.7, the answer will be 10.5. So what I understand, when I multiply 15 with a number which is greater than 1, the value is bound to increase. When I multiply this 15 with 1, the value will remain unchanged. And when I multiply 15 with a number which is lesser than 1, the answer will decrease. Now, why do we do this? That means if I want to increase a number, the multiplier has to be more than 1. Or we can say, the numerator of that multiplier should be bigger. If we want to increase a particular value, then in the multiplier, the numerator should be bigger than the denominator. What if I want to decrease it? Now look at 0.7, it is nothing but 7 by 10. So the answer says if I want to decrease this value, the multiplier of the multiplier's numerator should be smaller than the denominator. So in a layman's language, if I want to understand it, what I say here, that when I want to increase a number, in multiplier, numerator should be bigger than denominator, and if I want to decrease a number, the multiplier should be, in multiplier, the numerator should be less than the denominator. So how do we go ahead with this approach? Here we try to find a relationship between the unknown variable and known variables. For my convenience, I am drawing an arrow that is going from a known variable to a unknown variable, and I am drawing all the arrows in the same direction. The arrow does not have any significance as far as the question solving is concerned. It only says the movement has to be from this position to this position. Now look at it. What we will do, we will try to establish a relationship between known variable with the unknown variable. How will we do it? When the number of men increases and everything remains same. When the number of men increases, the days required to do a work will certainly decrease, because men are inversely proportional to days. More men require less days, less men require more days. So what we will do here? Since number of men has increased, number of days will decrease. So 24 has to be decreased. Therefore the multiplier should be such that numerator is smaller than denominator. More men, less days. I want to reduce this value, so numerator has to be smaller. Out of these two values, 4 is a smaller number which will become numerator, and 6 is a larger number which will become denominator. Another thing. Look at the relationship now, work and days. From here to here, the work has increased. If we have to do more work, we require more days. So that means now the number has to be increased, it means the numerator has to be bigger. I will say 3 will be the numerator and 2 will be the denominator. What are the hours per day? If somebody is working for 5 hours a day and now is working for 6 hours a day, that means he is putting more hours a day, we will require less number of days. More hours per day number of days required will be less. So we'll say 5 divided by 6. When we try to solve this equation, 3 2 is 6, 2 4, 6 4 is 24, and 5 4 is 20. So the total number of days required are how many? 20. So this is a simple example of the methods that we adopted here. That is unitary method. There can be many more examples, there can be many more variations which require certain more complications. But now to do this question, this is just one approach. There is a simple layman's approach. We say that work will always be multiplied with the opposite side. Now what do we understand with this? This work too will not be multiplied with the values of the same line. It will rather multiply with the other values. Let me assume this, instead of this question now we will put the x value. I'll say 2 will be multiplied with 6, 6 and x. Only in this whole figure, work is represented by this value. So we will say 2 into 6 into 6 into x is equal to 3 into 4 into 5 into 24. And if we try to solve this equation, immediately we will get the answer as 3 2 is 6, 2 2 is 4, and x will be equal to 5 4 is 20. So the same answer will come here. So this can be another method. We can discuss in detail later on. Now if I wish to apply this particular method, that is unitary method, in certain advanced level of questions, for example, it is said A is twice as efficient as B and thrice as efficient as C. B plus C together take 44 days to complete the work. Then how long will A, B and C take to do the work? Now, if I try to apply the same concept of unitary method here, I would prefer to do one thing. Let me assume the efficiency of A, B and C as some numerical value, let's say 6. Now, why 6 I take? Because I need a number which is a multiplier of 2 as well as a multiplier of 3. I took a value 6. Which means, if I say A's efficiency index is 6, then the efficiency index of B will be what? 6 upon 2, that is 3. And efficiency index of C will be what? 6 upon 3, that is 2. Now, look at the whole question. I am not concerned about the person's name. Instead of B and C had been X and Y, answer would not have changed. What will I say? My whole concern is with the efficiency. So, efficiency of B and C together is equal to 5 and the number of days they require is equal to 40. Okay? Question is, how long will A, B and C take to do this work? We will say the combined efficiency of A, B and C is nothing but 11 and the number of days required is unknown. So I have converted everything, rather than the person's name, I have done this, converted it into the terms of efficiency. Now this is a known variable, this is an unknown variable, known variable and unknown variable. The arrows are going in this direction. So when I go from here to here, what I find that the efficiency of the person has increased. So we know more efficient person will require less days. So friends, when we come from here to here, efficiency has increased. Therefore, when we come from here to here, days are bound to decrease. So to decrease this value, numerator has to be smaller, and the smaller between these two numbers is 5. My answer will be straight away 20 days. So this is just one variation that we can find out applying the concept of efficiency here and unity. What if I say the previous question that we took at the beginning, that A do a work in 10 days and B do the same work in 15 days? How long do they take to do the work together? Can we apply the concept of efficiency and unity method here also? For this, we need to understand the relationship between efficiency and days. They are inversely proportional. That means, if the ratio of the days taken by A and B to do a work is 10:15, that is nothing but 2:3. The ratio of efficiency will be absolutely reverse of it, that is 3:2. It means, if I take efficiency of A as 3, efficiency of B will be 2. Now I can do this question by using the information from A alone, or I can do this question using the information from B alone. How can? Look at this. A, whose efficiency is 3, completes this work in 10 days, therefore together A plus B, whose efficiency is 5, will take how many days? Now we know efficiency has increased from here to here, so days should decrease from here to here. That is 10 into 3 by 5, and the answer will remain 6 days. Similarly, if I want to solve this question by using value from B only, B, whose efficiency is 2, is taking 15 days to do the work. Therefore, together A and B, combined efficiency is 5, will take how many days? Efficiency has increased, so days are bound to decrease. 15 into 2 by 5, it will give me answer as 6 days. So you can see, once we know the basic approach, then we can apply to any situation, and then we can try to get the answer. Let me give you one last example here. Assuming it, the time taken by A to do a work is twice the time taken by B and C together to do the work. Time taken by B to do a work is thrice the time taken by A and C to do the work. If A and C or A and B can do this work in, let's say, 48 days, then how long will A, B and C take to do the work? So we'll try to solve this question by using an altogether different approach. Now what do I understand? The time taken by A is double the time taken by B and C together. That means efficiency of A is half the efficiency of B and C together. Now this is efficiency, okay? Similarly, efficiency of B will be 1/3 of efficiency of A and C together. So I understand one thing here, that if efficiency of B and C together is taken as 2, then the efficiency of A alone will be 2 by 2, that is 1. And in such a situation, their combined efficiency will be 3. I assume efficiency of B and C is 2, therefore efficiency of A will be 2 by 2, that is 1. And their combined efficiency will be 2 plus 1 is 3. Now, in another situation, if I assume efficiency of A and C as, let's say, 3 units, then the efficiency of B, A plus C is 3, then the B will be 3 by 3, that is 1, and their combined efficiency will be 3 plus 1, that is 4. Now in both the situations, there is only one common value here, that is A plus B plus C, A plus B plus C. But these two are different, so we cannot compare the other values. Let me equate this value. For this I need to multiply by 4, and this I need to multiply by 3. So I know 4 3s are 12, then I need to multiply everything by 4. So 4 1s are 4, and 4 2s are 8. Similarly, 3 4s are 12, 3 1s are 3, and 3 3s are 9. So what I understand, when the combined efficiency of A, B and C is 12, then efficiency of A and B is 4, A is 4, and efficiency of B is 3. Therefore, efficiency of C is nothing but 12 minus 4 minus 3, that is 5. What we did here, we equated this value. When efficiency of A, B, C together is 12, then A is equal to 4 and B is equal to 3. So 4 plus 3 7, so that left out for C is 5. Question says, if A plus B can do this work in 48 days. Now look at it. I can answer any question now here. A plus B, whose combined efficiency is nothing but 4 plus 3, 7. They do this work in 48 days. So what about A plus B plus C? We know A plus B plus C combined efficiency is 12. So the number of days required will be. When we go from here to here, the efficiency increases. Therefore, when we go from here to here, the days are bound to decrease. And to decrease 48, we need to multiply with the numerator, which is smaller than the denominator. So 7 upon 12, my answer will be 28. Now, all these questions can be done mentally. What it requires you to have is one, your concept should be clear, and at the same time, you need to practice many different questions in order to get the answers to it. So I hope this one small session was able to give you a basic direction about how time interval equations are done. There are still many more variations to come that we can cover at certain later stages. Thank you very much.